Hello everyone, in this video I want to look at a couple introductory examples of solving radical equations. And so before we start looking at this particular example, I want to outline the process or strategy we can use for solving a general radical equation. And so the first step, which is sometimes done for us but not always the case, is we want to isolate the radical on one side of the equation. And so a lot of times our radicals are just going to be quantities involving square roots or maybe some cube roots. And so we want to get the square root or the cube root expression by itself on one side of the equation. Hopefully that's equal to just some number on the other side of the equation, but it might be equal to some other function or other cube roots and square roots, just depending on how complicated the equation is. But in this example, that first step is really already done for us. We have the square root of x plus 5 isolated all by itself on one side of the equation. So the next step is we want to get rid of the radical or undo the radical, and the way we do that is by using exponents. We're going to raise each side of the equation by the appropriate power to eliminate the radical. And so for a square root, that means we're going to square or raise both sides of the equation to the power of 2. If we're solving a cube root equation, after we get the cube root expression by itself, we raise both sides of that equation to the power of 3 to eliminate the cube root. If we are working with an equation involving a fourth root, after we isolate the radical, we raise both sides of the equation to the power of 4. So after we've eliminated the radical by raising both sides to the appropriate power, we'll have some new type of equation left over. It may not be a radical equation at all, or it may still involve some radicals, in which case we got to kind of go back through those earlier steps again and again until all the radicals have been eliminated. That's really not the kind of problem we should be running into in these early examples, though. We should end up with some simple linear or quadratic equation in most cases. Once we have that equation, we then solve it and find our answers and values for x. However, we have to be really careful, and that's what this final step is asking us to do. To be careful, we have to check the final answers we end up with. We only keep these solutions to the very original equation. So let's go ahead and work through this first example now. Let's solve the square root of x plus 5 is equal to 3. Like I mentioned earlier, that first step is already done. We've isolated the radical. The square root is by itself on one side of the equation. The next step in our process of solving this is to square both sides of the equation or raise both sides of the equation to the power of 2. When we square a square root, it cancels or undoes the square root out. And so when we square the entire square root of x plus 5, the square root and the exponent of 2 cancel each other out. And we're just left with what is underneath the radical, in this case, the quantity x plus 5. So the quantity x plus 5 is going to be equal to the right-hand side squared, which is 3 squared, or 9. And so by squaring both sides of the equation, we've resulted this new equation that does not involve a square root. It's a much simpler equation to solve. We can solve this linear equation by subtracting 5 from each side. And then we have x is equal to 9 minus 5, which is 4. So that is our answer, but we should check our answer really quickly. If we plug x equals 4 back into our original equation, we get the square root of 4 plus 5, or the square root of 9. And the square root of 9 is equal to positive 3. So we checked our answer, and it does solve the very original equation. All right, so that first example of solving a radical or square root equation wasn't too bad, but this next example will be a little bit more involved. So here we want to solve or find the solutions to 2 times the square root of the quantity x plus 7 plus 11 is equal to 5. And so in this example, our square root is not isolated. It is not by itself. So our first few steps are going to be helping us get that square root all by itself. And so let's see, our square root is multiplied by 2 and also has 11 added to it. So if we want to get that square root by itself, first we're going to undo that addition by subtracting 11 from each side. If I subtract 11 from the left-hand side, I'm left with 2 times the square root of x plus 7, but I have to also subtract 11 from the right-hand side, so we have to do 5 minus 11, and 5 minus 11 should give us negative 6. And so now we're closer to having our square root isolated by itself on one side of the equation, but it's still multiplied by that factor of 2. So I'd argue that it's not totally by itself. It still has that kind of buddy hanging out with it. So let's finish getting it by itself, get the square root of x plus 7 isolated by dividing both sides by 2. And so if we take negative 6 and divide it by 2, the result of that is going to be negative 3. And so now this modified version of our original equation says the square root of x plus 7 is equal to negative 3. We've now isolated the radical on one side of our equation, so we're ready to move on to the next step where we get rid of the radical or undo the square root by squaring both sides of the equation. So if I take my square root of x plus 7 and square that, that'll be equal to the right-hand side of negative 3 squared. Well, when we square the square root of x plus 7, that cancels out or undoes the radical. And we have to be careful when we square a negative number like negative 3. That will result in a positive number. In this case, negative 3 times negative 3 is equal to positive 9. So again, after we undo the radical, we're left with a much simpler equation. We can solve this in one more step just by subtracting 7 from each side, and 9 minus 7 is equal to 2. So it's looking like our answer is x equals positive 2. However, we have to be careful. Let's go ahead and carefully check this in the very original equation that we started with. So if we do 2 times the square root of x plus 7, well, that's going to be 2 plus 7, which is 9, plus another 11. Does that give us 5, or does it give us something else? Is this equation true or not? Well, the square root of 9 is 3. So then we have 2 times 3, which is 6. But 6 plus 11 is not equal to 5. 6 plus 11 is equal to 17. So this is an example of one of those extraneous solutions that we cannot include in our answer. So x equals 2 is not part of our solution set. It was the only x value we found, though, and since we just got rid of it, that means we have no x values that solve this equation. So this equation, we would say, actually has no solution. So here we've seen an example of why we do have to be careful and check our answer in that original equation, because it may not actually solve that original equation. And actually, we could have noticed this a little bit earlier in our work, right about here in this line. After doing some manipulation and modifying our equation, we got to this point that said the square root of x plus 7 is equal to negative 3. But if we think about how these square roots operate, square roots always spit out positive numbers. So there's no way the square root of x plus 7 could be equal to negative 3. So at that point, we could have stopped and been like, hey, this is an impossible situation. We're not going to have any solution to this situation. So our equation must have no solution. Either you can notice it earlier on, or you can notice it at the very end by checking your answers. Either way, we have to keep an eye out for that scenario. All right, let's take a look at solving another radical equation. Still going to be a relatively basic one, but a little bit different because now we are working with a cube root expression instead of a square root expression. But the process, for the most part, is the same, or at least very, very similar. And so that process starts by isolating our radical, this time isolating the cube root expression, and well, that is already done for us. So we're ready to move on to the second step of our process, where we raise both sides of our equation to the appropriate power in order to eliminate the radical that is involved. And so because we are working with a cube root in this equation and we want to get rid of that cube root, we're going to have to raise both sides of the equation to the power of 3 to help us do that. And so that cancels out the cube root on the left-hand side, just leaving us that quantity underneath our radical, which is sometimes referred to as the radicand. The terminology is not really that important. What's important is we understand and know that the power of 3 cancels out the cube root of 3, and we're just left with 3x plus 6 on the left-hand side. Now on the right-hand side, we have negative 2 raised to the power of 3, and that's negative 2 times negative 2 times negative 2, and that'll be equal to negative 8. And so now we're left with a much nicer equation, much simpler to solve. We can do it in 2 steps here. First, we can subtract 6 from each side, and that'll give us 3x is equal to negative 8 minus 6 is negative 14. And And then we can get x by itself by dividing away that factor of 3. And our final answer ends up saying x is equal to negative 14 over 3. And technically, we don't have to really check our answers when we're solving these cube roots or these odd rooted equations. It's really just for the even roots like the square roots. Well, odd roots and odd powers work well with negative numbers, and that's just not the case for even roots like square roots. But if we want to check our answers just for good practice, we can plug negative 14 over 3 into our very original equation. If we do that, well, we get the cube root of, well, 3 times negative 14 thirds just gives us negative 14. And then negative 14 plus 6 is negative 8. And the cube root of negative 8 is equal to negative 2. So that is our answer. We don't want to get rid of it. The solution to our original equation is x equals negative 14 over 3.